Hi everyone, this is Zoe. I'm from Vernolar. Today I'm going to talk about AV1 for RTC. I know there's another talk actually from Marco talking about AV1 for RTC, and actually we were once a very close colleagues working on the AV1 project back at Google. And today is mainly I'm going to take this presentation. It's mainly to take Aurora1 AV1, which is our own encoder, as instantiation of AV1 to show the state of the art and great potential of the AV1 standard for its deployment in the RTC sector. Here is just a slide showing about what is AV1 and then the Lights of Open Media, which is the standard organization behind the AV1 standard. So everybody knows that AV1 is an open source video codec standard. It has been developed and further contributed by close to 50 the AOM members. Here, we want to emphasize that AV1 actually from day one to make its standard really amenable for its deployment in RTC. Why? We can see that it's the version 0 of one of the AV1 open source encoder libAOM is actually starting from libVPX VP9. We know that VP9 has been with the WebRTC, the open source, well-acknowledged RTC platform for a long while. So with so many developers cooked for VP9 to make it deployed in the RTC real world, it also have a lot of good features has been inherent by libAOM, by the AV1 standards to make this really some intrinsic features to amenable for RTC deployment. In particular, we want to mention one feature, the screen content coding. AV1 is the codec standard for the first time to include the screen content coding tools in its main body. IntraBC has also made screen content coding tools, but only in its extension. Screen content is very different from all the other content. Here I'm showing the slides. Screen content have really a wide usage and in the RTC, like here, video conferencing or remote learning or remote desktop sharing. So there's so many RTC use cases that cannot leave screen content aside. And screen content, we see that it has limited colors, it has sharp edges, has repeated patterns. A lot of these make it very unique. And then the coding tools inside AV1, such as libv, the IntraBC and Tally mode really make good of really take the specific features of screen content and then dedicate the specific coding tools to handle this screen content coding really well. That I'm going to show quite some examples in my presentation later on. And we also want to show that what's the ecosystem of AV1 right now. And it's mainly about the hardware decoding. And it's already a lot of chip vendors have dedicated and have rolled out their new products that have supported hardware AV1 decoding, such as MediaTek roll out Dimensity series to have chips ready to be deployed on the mobile side. And there's AMD, Intel, NVIDIA, and for also announced that their support of already actually rolled out the AV1 decoding chips, and Broadcom really guide their hardware decoding support to put into set-top box. And also we have a lot of actually state-of-the-art TVs ready to support AV1, not only HDR, but also 4K, 8K hardware decoding. Besides the hardware decoding, we have to say that, especially for the RTC world, there's many use cases that we have to deploy software decoder. And software decoder also make it something easier, especially for RTC, to have applications deployed across all kinds of different platforms. There's quite some open source software decoding available for AV1. In particular, we want to mention David, which has been mainly funded by AOM and developed by the Video LAN and FMPEG community, making David a fantastic software decoder for AV1. And the decoder side development and achievement make AV1 really ready for its deployment in the RTC sector. First, we want to give example. Aurora1 AV1, as I just introduced, is our AV1 encoder developed by our Veronular team. But we want to really say that is we always stand on the shoulders of giants to climb further up, meaning that we benefit a lot from the open source community. So there's several well-known AV1 software encoders open source down there. We really benefit from them. So taking Aurora1 AV1 as an example, here we just want to show that is AV1 is not only an open source standard, not only that it has included many new coding tools to make it very coding efficient. At the same time, there's a great potential. We can optimize AV1 encoder to make it fast enough so that it's ready for the deployment of RTC. So here we give example for comparing Aurora AV1 against the well-known X264 open source H264 encoder. In particular, we compare against X264 medium, because that's also the request from many of our customers. They want to say that, how do you compare your encoder against X264 medium? Whether you can still maintain the codec standard advantage of AV1 while making AV1 really fast enough. Whether it's fast enough, for example, how do you compare the speed to X264 medium? In this slide, what we show is we take a AWS C5 machine. It has a 16 cores, 32 threads. So in this 16 cores, we want to see what if we get one video and let the 16 core dedicated to encoding of this one video live, meaning that if the video is a 1080p 60, and meaning that it has 60 frames per second, then encoder has to be fast enough to be able to encode at least at speed of 60 frames per second. And then we want to try if it can really live encoding this one video. What if we got two instances, meaning that two live streams concurrently on top of the 16 core, whether that can still be handled, both streams can be encoded live. And then what if we have three streams concurrently, meaning that, for example, we use FMPEG to encode this video 3 times, and 3 streams concurrently, whether can all the 3 streams can be encoded live on top of the 16 core. What if 4 until we try 6 to see whether all of them can share the 16 core computing resources and the live encoding in real time concurrently can still stream out this 6 streams concurrently in live. So we try this, but we also know that for different content, for different videos, that means the encoder speed could vary a lot. So we take 20 videos and then encode them one by one. And for each of the video, try 1 concurrent, 1 stream, and 2, 3, all the way to 6 concurrent streams to see what will be the maximum number of streams this machine can handle. Let's take the left figure. On the very left, it is X264 medium. And then we also try X264 fast and faster. Now you can see that it's when we got only encode 1 stream, all the 20 videos can really be encoded by X264 medium encoder in real time. But then when we start to get 2 streams concurrently, only left 11 out of 20 can be handled in real time. The other 9, their encoding speed cannot reach to the source frame rate. That means that it cannot be streamed out concurrently for 2 streams for that specific video characteristics. When we increase to 3 concurrent streams, we see there's only 2 videos left. Then when we increase to 4, 5, 6, then no video can really be encoded real time with so many concurrent streams altogether. This is how X264 medium perform. What about AV1? And then on the right of the figure, that is where we show the performance of our Aurora AV1 with also 3 different speed levels. Let's just look at the relatively slower, which is very fast. Now we can see that still if only 1 stream, all the 20s can be handled, no problem. When we increase to 2 concurrent streams, 17 out of 20 can still be encoded real time for 2 live streams. That means that Aurora1 very fast, this speed level is already faster than how X4 medium performs. That means that there's a quite potential we can make AV1 faster. What about the code efficiency? So now underneath this figure, this slide, we gave the table. It shows that, for example, you just look at the first line. That's where we compare Aurora the very fast compared against X4 medium. We can see that is actually maintained a more than 40% BD rate gains, meaning that AV1 is really can maintain a good code efficiency while even can be encoded at a faster speed compared to X4 medium. So from this slide, we just want to show that is indeed there's a potential and there's actually it's not just a possibility, that's really real that AV1 can make faster. So let's see how AV1 performs in the RTC scenario. We already mentioned that AV1 is really good at screen content. So let's just encoding screen content. We actually take one video from the GCT-VC SCC set. So that's the testing set by MPEG to try for the expert group of screen content coding for HEVC. So we take one example out of that set. It's untrained 444. We down sample to 420. It's a 720p video. And then we first encode here by X4. It's actually still the medium speed level. And then the resulting bit rate is 169 kilobits per second. This is the quality that we see. This is a number 268 frame out of that video sequence. So it still can be sort of barely legible. There's some words that's not clear. How about AV1? See, this is the AV1 result. It's encoded by Aurora AV1 actually at a lower bit rate. It's about 17% less bit rate consumed by X4 medium, but the quality is significantly better. This means showing that for screen content coding, AV1 has a great advantage compared to X4, which is basically representing state-of-the-art, the quality that the current a lot of RTC system has delivered. And further down, we just gave out a few slides looking into some real data comparing Aurora AV1 against different encoders for screen content coding. So this is against OpenHCC4. Now we can see that overall, there's a BD rate gain about 25% to 50%, depends on which objective quality metrics that is being used down here, either PSNR or SIM or min-max. So it still shows that Aurora1 very fast is more code efficient than OpenHCC4. But OpenHCC4 is a really fast encoder. That means that Aurora1 is actually about 38% slower. But look at the frame rate per second is actually not bad. All these are tested over one thread over the PCs. It's about either Intel i7 or it could be on AMD Ryzen machines, one thread. So we can see that is actually the absolute frame rate per second is not too bad. It already can deliver the screen content. All this is about 720p or 1080p videos in real time. In particular, we want to mention that many of the time, screen content do not have to be that many frame rate. Usually 15 frames per second, this kind of encoding speed is already more than sufficient. So this indeed shows that AV1 has a great coding efficiency again, compared to OpenHCC4, while it can really deliver in real time, making it already been ready for the RTC. Now we compare another AV1 encoder. I know that already been talked by Marco. We just gave example for what further can be optimized on the AV1 side. We always mention that we stand on the top of the shoulders of giants. So we actually learned a lot from the open source encoder. We just try to get a little better. So here we show that there's a code efficient BD gain that we can get at almost the same encoding speed as LibLMRT. And all those two slides showing that the screen content coding capability that can be done by AV1. And here we just, what if the camera content? Here we start on showing a result on the mobile platform. Actually, we take a Snapdragon 845 and running different encoders on top of it. And all these are actually on the lower, not that high. It's about like a 240p type of, or even smaller resolution to see how they can be encoded real time on the Snapdragon 845 mobile devices. Again, it's still trying to use one thread. And we compared against X64 with the different speed levels, VP9 with 2 speed levels, and OpenX64 with 2 speed levels. Here we take X64 medium as the anchor. So the vertical shows that all the BD rate as opposed to the X64 medium, and the horizontal shows the absolute frame rate per second. That is the encoding speed, meaning that when the curve towards to the top, that means BD rate is worse, meaning that is less coding efficient. And when it goes to the right or to the left, horizontal is the absolute frame rate. So to the right, meaning that the faster speed that can be achieved. To the bottom, meaning that is a higher coding efficiency that can be achieved. Each curve of different color represent one encoder, and different dots on top of the curve represent one speed level. So from here, we can see that this is a potential and show the great performance that Aurora1 can achieve because it's maintained more than 20% of a coding efficiency gain as opposed to the anchor, and it's also fast enough. And it's about 225 to 150 frames per second. That's kind of encoding speed on the mobile device. And further down, we have some closer camera content type of comparison. This is again compared against LibreOMRT, showing that there's about 20% bit rate gain, but with about 10% lower speed level. And then here we compare against the most recent version of SVT AV1. They just released the version of 0.9. Here we compared against their preset 10. So they have rolled out new speed levels from 9, 10, 11, 12, 13. So we chose a little bit slower in this slide against the preset 10. And Aurora1 actually can achieve about 25 to 35% bit rate gain while running at a much faster speed, about more than 40%. And this is for the single thread comparison. So it's showing that there is a larger potential that we can make AV1 faster and better. So this is again preset 10. And we use the same Aurora1 result compared against the preset 12 of FATV1 because SVT1 became faster. And here the comparison showing that now Aurora1 actually run at a slower speed, about 30% slower, but maintain a better coding efficiency gain, about 35 to 50% bit rate gain that can be achieved. Again, Aurora1 for the next step is trying to get even faster speed, and then of course have to compromise some of its bit rate gain. So on top of this, after we compare Aurora1 with existing state-of-the-art encoders, what it showed that is better and it's faster, it's really ready for the deployment. For RTC, we want to see some other functionality because for RTC scenario, AV1 really need to have some scalability capability. So that Aurora1 has that similar to what Deliver has already been delivered by LibreOM. So we provide 2-layer or 3-layer temporal scalability. And we also provide across different platforms versions for Aurora1. So PCs, we have the version ready for Windows, Linux, and macOS. For mobiles, it's mainly Android and iOS. And also we support not only x86 architecture optimized version, but also ARM version for supporting the mobile platform together with the macOS using the M1 underlying CPUs. And on top of it, we actually show that Aurora1 Encoder SDK can put very relatively smaller size. Right now, it can be like significantly smaller than 1 megabyte. So that makes it smaller to be deployed potentially over the mobile platform. We even have integrated Aurora1 with a WebRTC platform already. So it's quite relatively easy to integrate our encoder ASCII with WebRTC to make it ready to be deployed over the mobile platform. Here we have a demo that actually everybody can ask, send us an email per request. We actually leverage there's an app called WebRTC Mobile. It's GitHub open source that you can get. We actually integrate our Aurora1 AV1 together with a few other software encoders so we can play the app to try out different encoder performance on top of iPhone. And on top of it, we just want to say that it's very important to think about decoder side. We mentioned David already. So here we give the result how the David as an AV1 software decoder compared to other 264 and open source HEVC software decoder in all kinds of different performance like a power, battery life, and what if it's running on the mobile, the temperature. So we measure that on top of Snapdragon 845 and with 1 megabits decoding and 2 megabits decoding scenarios. It's actually the conclusion can be drawn that is the complexity of the decoder of AV1s actually in terms of power consumption is positioned between the 264 and the HEVC open source decoders, meaning that the AV1 decoder really not complicated. In particular, there's a new version that has been released by David dedicated for the optimization for the mobile platforms. On top of it, once we already mentioned in our previous presentations that AV1 on the encoder side can be further optimized for the decoder side complexity reduction. So it's really, we not only can just try to optimize AV1 encoder for better coding efficiency, for better encoding speed, but also for better decoder side complexity optimization. And then on top of it, there's a lot of work we can do for further optimize AV1 leveraging the so-called AI technologies. And we don't want to say that it's AI is always like deep learning because that's also going to get a lot of complexity to the encoding. But there's quite some optimization that we can done leveraging a combination approach, leveraging the AI, leveraging the neural network kind of approach to make it really adaptive learning together with a traditional codec optimization scheme to really make encode even faster and better. Lastly, we'll use 2 slides to introduce about us. Already mentioned we are VeriNuller. We are a team dedicated to encoder optimization. And we have just different kinds of encoders. So definitely we are a big fan of AV1. We really want AV1 to be really stretched to its great potential and to be widely deployed. Indeed, we share the vision that we want every user in every corner of the world can enjoy the best possible video experiences. Our team has close to 60 members already. So we are relatively not that small anymore. And across the continents of North America, Asia, and Europe, we actually already launched our encoder with more than 55 paid customers. It's enterprise customers. In particular, quite some of them already deploy our Aurora1 AV1 encoder. So we want to show this that AV1 is not just lab research anymore. It has already been purchased by our customer in the sector of live and in sector of VOD and particularly in the sector of RTC that they're starting to deploy AV1 to make it really beneficial to a lot of video experience users. And we also appreciate that AOM has also mentioned our product and our progress in the website. In particular, we are again a big fan of AV1. We have a dedicated page, av1info.com. In particular, we make some videos and for fun by our great team members. We call it AV1 Mythbusters. You're welcome to visit and watch those videos to see how amazing AV1 can particularly bring to the world. Okay, that's concluded my talk. Thank you very much. And if any question, you're welcome to draw us an email or visit our website at verinuller.com. Thank you.